Please note today's session is being recorded. If you have any objections, you may disconnect at this time. Thank you very much. On behalf of the National Cancer Institute, I wish to welcome everyone to the Advanced Topics Implementation Science webinar series. We are very excited to be joined by our speakers. Before we get started, a brief word about logistics. We ask that if you are not already on mute to please keep your phone on mute for the duration of today's presentation. As mentioned, the session is being recorded and muting all lines will help us to avoid any background noise. We encourage questions. They can be submitted using the Q&A feature on the right-hand side of your screen. Type your question into the provided Q&A field and hit submit. Feel free to submit your questions at any time during today's call. You can also keep an eye on the chat box where we'll be posting resources mentioned throughout today's talk. And with that, I'll turn it over to David.
Thank you very much, Sarah, and let me add in my welcome to all of you who have joined us over the next hour. We're very excited to have the latest in our series of fireside chats. As the weather is starting to get a little bit warmer, we will at some point move to the campfire, but at the moment we're still in the fireplace. For those of you who haven't been a part of these particular sessions, they run a little bit different from the typical webinar in that we're really trying to have as much of a conversation with as many of you who want to participate as possible. And so what that means is that we don't have, although you'll see occasional graphic prompts that you can enjoy, we don't have the typical PowerPoint slides, but rather are taking the opportunity to learn from our two experts who are joining us and to take on this particular topic, which is basically looking at how system science and implementation science can come together. So we're grateful as you see the pictures of these wonderful people in front of you. We're grateful to have Stephanie Wheeler, who as you can see is Associate Professor of Health Policy and Management within the UNC Lineberger Comprehensive Cancer Center, and Lindsay Zimmerman, who is a clinical and community psychologist, focuses on implementation science within our National Center for Post-Traumatic Stress Disorder at the VA Palo Alto healthcare system. Both of these experts have joined us in recent years for some of our different training programs. I first met Stephanie when she took on the reins for our NCI and CDC co-funded Cancer Prevention and Control Research Network. UNC, and under Stephanie's leadership, is the coordinating center for that ongoing network, and got to know Stephanie a bit more through the funded mentored training on dissemination and implementation research in cancer. And so she came to us, and I think she'll share some of these impressions, with a great track record and great experience around system science, and then was thinking about how implementation science might fit in. Lindsay, I met through our Training Institute for Dissemination and Implementation Research in Health a couple of years ago, and Lindsay was one of the few trainees who was actually also asked to present at the in-person portion of that training because of her expertise and her experience in modeling. And so it's a wonderful chance for us to welcome both of them and to engage all of you in whatever questions you have over the next hour about how we can advance together the system science applications to take on important implementation science questions. So Sarah gave you the sort of ways in which you can join the conversation and ask the questions that you have. But we wanted to start off just by asking first Stephanie and then Lindsay if each can talk a little bit about how you became first interested in implementation science, and then how you started to think about the integration of system science and implementation science. So welcome, and Stephanie, maybe you can start us off.
Sure. Can you guys hear me all right?
Yep.
Okay, terrific. Well, thank you so much to David and Sarah and the whole NCI crew for having me here today. I'm really looking forward to the conversation. So as David mentioned, I was originally trained as a decision scientist, which is sort of a branch of system science, in my doctoral program at UNC Chapel Hill. And my methods training for that degree focused particularly on quantitative decision and system science methods. So that included simulation modeling, epidemiologic modeling, econometrics. And part of that was always implicit that we needed to have a deep understanding of complex systems. So we needed to think about fragmented healthcare systems, intersectional social determinants of health, and multi-level influences on policy and cancer outcomes. So I would build these complex applied mathematical models to project things like health impact at the population level or cost effectiveness of this treatment or that program. But when I joined the faculty at UNC, I realized two things. One, using exclusively quantitative methods didn't cut it, especially when quantitative data were unavailable or low quality or just didn't ask and answer the right questions. I definitely needed more qualitative approaches in my toolkit. And then two, modeling for the sake of modeling or thinking about complex systems for academic gain didn't move the field forward in any meaningful way. I really needed to think about how to translate the lessons that we were learning in system science into practice and policy. So I had to figure out, how do you cross this chasm between evidence and action, which of course is something that implementation science has been tackling for quite some time. So that's when I started reading more about implementation science, and I wrote a American Cancer Society K Award equivalent to gain mentorship and exposure in the implementation science space. Brian Weiner was one of my mentors, and was really terrific in getting me started. And then eventually I joined the MT Dirk Fellowship Program, and that's really where I jumped into the deep end and had to learn how to start swimming in implementation science.
Cool. Great, Stephanie. Lindsay, same question to you, how you started to get involved in these areas?
Sure. Can you guys hear me? Okay.
Yep.
Okay, thanks. So I am a clinical and community psychologist by training, as you mentioned, David, and while I'm a licensed clinical psychologist with hospital privileges at the VA, I would say the majority of my day-to-day work in my implementation scientist position in a dissemination and training division is classic community psychology practice competencies. So participatory research, organizational consultation, program evaluation, and quasi-experimental research designs, policy and systems change. These were sort of the bulk of my training on the community psychology side of my graduate work. And we covered implementation science in my graduate coursework. Some of the early work in the D&I space was done by community psychologists like Abe Wandersman, for example, from the University of South Carolina. And so even in grad school, I was doing work with getting to outcomes with the CDC as part of my mentored practicum work in graduate school. And a big part of me choosing my graduate program was I was drawn to my primary mentor, Lisa Armisted's work, because she always had community advisory boards and always was working in locating her work somewhere on the community engaged or stakeholder engaged dimension that I thought was really important, and I thought our scientific values were aligned. And so I think that's a really big part of my home base in terms of thinking about implementation science. I've sort of been baked in, or it's been baked in, I guess you could say, from the very beginning of my training. And it was community psychology that also introduced me to system science. So several years back at one of the research meetings that community psychologists have, the Society for Community Research and Action, I ran into community psychologist David Lounsbury, who I've been working with now for some time on our work in the VA. And he was presenting a simulation model that he had built with a variety of stakeholders and was showing HIV viral suppression among women of color who were using the New York City Health Department for their care. And so you're showing this population level health outcome. And when he was explaining that they sort of built the model from the ground up with service consumers and frontline staff, I was like blown away. And I asked to meet with him right away, and we followed up with each other then, but I hadn't actually accepted my implementation science position in the VA. That was, going to be sometime in the future. And once I did later accept the implementation science position, I was listening a lot to my colleagues who've been innovating and spreading evidence-based psychotherapy nationally in VA for nearly a decade at that point. And a lot of their data was starting to point to, okay, well, once we've trained people and once people are trying to do this out in their clinics, a lot of people were describing what we might call system barriers to their ability to reach more veterans with these treatments. And it really occurred to me that what we needed was that thing that community psychologist David Lounsbury had been doing. And before long, we had met and started talking to more and more stakeholders, and an outpatient mental health director invited us to try to pilot a system science approach. And that 4-year participatory effort is still underway. So I think I came maybe from the opposite. Stephanie and I have talked about this many times, but kind of came from the other side where I was beginning to see why even if you were doing really great stakeholder engaged work, you might want something more like a simulation model, more so than some of what I had been trained to do, mainly to that point, which was more mapping or logic model development or process flow. And I really wanted something that could efficiently help stakeholders know what would improve their implementation outcome, in our case, reach of these practices among the patient populations. Why would it work? Under what conditions? I didn't want to just have an it depends answer. And I thought, okay, maybe simulation modeling and system science could help resolve barriers to consensus among stakeholders, could help us place a better initial bet about any implementation plan we might try. And so that's how we got started.
Cool, thanks. And so I would guess that in terms of who's listening into this, that there's going to be a range of people, people who have a range of exposure to system science. And I'm wondering if each of you might be able to comment on how you've seen the activities around system science advance in recent years, and maybe you know, as you see it being particularly relevant to implementation science. And Lindsay, maybe we'll start with you and then go to Stephanie on that.
Sure. Well, I think it's sort of telling. I'll do my best to contribute to living up to this name that we're still in the advanced topics category. So I think that the field has been trying to emphasize system science for some time in the RFAs, including the standing D&I PAR at NIH. And it's something that I have been hearing people be interested in for a really long time, and that's really great. What people who often come to me don't know how to navigate is, you know, how do I choose the right modeling approach? What's the difference between a model versus modeling? What kinds of decisions am I supporting? You know, do we go on to full bore running simulations? Do we stop at more mapping kind of approaches? How do I dive into this discipline and benefit from maybe what's already out there? I mean, in my case, a real draw was that through the work of Peter Hovmand and his community-based system dynamics book, and then even decades before that book, other system dynamicists, which is the type of modeling that we ultimately thought fit our EBP reach, meaning reach of evidence-based psychotherapies and pharmacotherapies among our patient population. By the time that became our key implementation outcome, it seemed that system dynamics was the right level of aggregation for our decision makers. And I'll be happy to unpack that more because I'm sure this isn't enough yet. But as the field has kind of moved from some of those early Patty Mabry efforts and said, okay, system science includes social network analysis and agent-based modeling and system dynamics, I think people are getting a little clearer that there's lots of options out there and that they don't have to reinvent the wheel perhaps, but they're not totally sure how to make those decisions about what type of approach and how much multidisciplinary expertise do you need? Do you need to have a Dr. Wheeler who's, you know, just a total expert in this, and how could I get started? That's kind of where I see some of the current learning edge. And for me, I think some of the big draw is that people are coming to where I did in the Hovmand book and others, where they realize that some of these traditions have been talking about doing this in a group-based, stakeholder-engaged way for decades of their scholarship. And that, for me as a participatory researcher, was a real draw to think about using participatory modeling as a way to get people on the same page and maybe pursue more effective changes in their setting. So I don't know. What do you think, Stephanie? That's my first stab at that question. What have you been noticing?
I think that's terrific. So I would absolutely agree that the NIH having targeted opportunities for funding in this space has been a huge catalyst. I also agree with you that there's this host of tools that are available for system science work, and you named a few of them. You know, there's agent-based modeling and systems dynamics and social network mapping and process mapping, and you know, there's others too. I mean, system support mapping, of course, larger simulation models, causal loop diagramming, you know, even discrete choice experiments. I mean, there's a whole suite of quality improvement based tools that are available. I think what has been challenging for folks, as you've noted, is figuring out what is the right system science methodology for the right research question at the right time in the right context, right? So there's a lot of rights in there. But, you know, so many of the stakeholders that we work with have priorities and questions that are quite different from an academic's research question. Or they have varying levels of understanding of how these tools potentially could be useful to them. And so we have some education work to do. I think what has been nice to see is the integration methodologically of a lot of different disciplines into the system science space. So initially, maybe healthcare system science was focused on an engineering and operations research kind of route. And that root system has really broadened to encompass a whole range of different multidisciplinary approaches, you know, from business, psychology, sociology, behavioral sciences, even evolutionary biology, and of course epidemiology and economics as well. So that broadening umbrella, if you will, has brought a lot of different people to the table, and it's been really fun to engage in conversations that really are focused on bringing together all of these methods and then figuring out together with our partners in the community, what do you need? Like, we have a lot of tools. We have a lot of hammers and saws and, you know, all kinds of things that we can use to be helpful, but there's no point in building anything if it's not going to be used and not going to be helpful for you all. So that's been good. The other thing I would say is that in addition to the NIH and CDC's investment in this methodology, as well as many other funders, our professional organizations are coming together in a major way to bring attention to the intersection of these two fields. So Academy Health has a healthcare delivery system science fellowship that people can participate in. In addition to that, graduate training programs all over the country are expanding their curricula and degree programs in system science and implementation science. Many of those educational opportunities are housed within the same department, like our own Department of Health Policy and Management here at UNC. And so that training ground offers a lot of opportunity for cross-pollination and cross-training, which I think is absolutely what we need.
Great, thanks so much. And just a reminder to folks that it's never too early to start thinking about what comments or questions you have, either questions to pose to our experts or comments that you'd like to make to add to the conversation. And as they come in, of course, I'll be happy to weave them in to the conversation as deftly as I might be able to. If you are watching the slides, you'll see that there is a rather lovely picture of a fireplace. So just to note that comes courtesy of Sarah's ability to find copyright-free art, I think. So anyway, just a note about that. But wanted to then ask you a question about, so as you're tracking the field and you know, advances, as you've said, in how we think about different appropriate system science methods for implementation science, where do you see the field moving forward? Where do you see modeling or other system science approaches to implementation science going in the future? And Stephanie, do you want to start us off, and then Lindsay?
Sure, I'd be happy to. So I have a few thoughts on this. I think one kind of short thing I'll say is that our computational capabilities need to improve to really meet the needs of complex system models. We have a colorectal cancer screening simulation model that we've been developing and honing for many, many years now, and it can take several days to run in some cases because it's really a mirror of the exact population of states like Oregon and North Carolina. And that is really just a computational limitation at the end of the day. It shouldn't take that long, and this is a place where things are rapidly changing and advancing. But to do some of the work that we want to do, especially as we move to national level computational models, we're going to have to find a way to make that more efficient. I would say that we also need better templates for doing system science and implementation science simultaneously. And I think that this has to include training models for the next generation so that we can develop workforce in this space at the intersection of the two. Currently, there's clearly some people working at the intersection of system science and participatory implementation science, Lindsay and I and others. But it seems to me that a lot of people who are doing this work are figuring it out as they go, and just kind of trying out different approaches of using system science tools with stakeholders without a ton of guidance or best practices yet. And I think we have a lot of work to do to develop those. So you can't just go into a federally qualified health center and start putting up cost-effectiveness efficiency frontiers and comparing evidence-based interventions against each other and expect that the clinic director is going to go, oh, okay, wow, now I see what we should do. We have to be a lot more thoughtful about how we engage those decision makers and finding out first what evidence and information they need to make decisions, what they're telling us is or is not possible within a given context. Maybe they first need a process map to really understand how their current system is functioning, where things are breaking down, where the bottlenecks are. Maybe they don't need a cost-effectiveness analysis at all, but so many people who are methodologists, including a lot of decision scientists and system scientists, they want to use that hammer wherever they go. And I think that we have to be really cautious before we take that sort of approach. So I think in the future we're going to have development of best practices in using this kind of methodology for a variety of different stakeholders. I'll stop there.
Great. Lindsay, your thoughts?
Yeah, Stephanie said a lot of good stuff there about the need to, continue to develop this at the intersection of system science and implementation science. I think I've been thinking a lot about our interest in causal mechanisms and what a system science approach to answering that question would mean. Some things that I really like about the history of the system dynamics modeling that we have ultimately landed with include, as I already mentioned, I'll use academic jargon to say this, the epistemology that you need lots of stakeholders embedded in different places in a system to really understand a system problem, and that we're modeling a problem and trying to figure out, we're not modeling a system in the sense of like the healthcare system so much as the fundamental dynamics of our problem. And in using, in our case with our modeling, calculus, we're reading in data and literally trying to come up with plausible trajectories that a local clinic might be on. So we take general causal dynamics that we think are in play everywhere, and we do local calibration to find out what's in play locally for a clinic. And so for me, what's really exciting about that for the field of implementation science is the possibility that once a modeling project is sufficiently developed, and not all projects may call for this, that we really could add a significant value for a team trying to get a sense of, well, should we try Sarah's idea or David's idea or Stephanie's idea? Which one gives us the most of what we want with the least negative consequences? And we can zoom in and out on a variety of important variables so that we can see when there's a trade-off in wait times for patients or between patients with different needs, or we can figure out how to reallocate our staff effectively. And so things that we normally in implementation science across our many, many frameworks talk about as verbal constructs, like limited staff or limited time, become quantities. And at least the way that we've been doing our modeling, reading in things from the electronic health record, we're reading in sort of the same major dynamics in play for a service setting, locally calibrating it with the local staff and patient data for a given community, and trying to come up with a really locally optimized strategy that the team might try. And so for me, what I'm excited about for implementation science is that this is moving into much more general theories about how systems work. And some of the very early system dynamics papers cite Nobel Prize winning decision scientist Herbert Simon, and the idea that we're minimal satisficers, meaning we come up with minimally satisfactory solutions that will suffice. We don't have time to make optimal implementation plans all the time. We're often making a lot of little decisions all day long about patient care, at least in my setting, like when should I see this patient back? When should I refer them for a new treatment plan? And we're flying blind with regard to what those decisions aggregate up to in our clinic. And again, a model tailored to that type of problem meant to address those types of rates of patient flow through states in care, look at wait times, look at how you're allocating your staff, can start to tell you something where the mechanisms in play are truly causal mechanisms guided by basic science theory, but really locally tailored if you're reading in local data. That's how we've applied it. And so for me, what I love in terms of moving the field of implementation science forward is, one, we're not just at the framework level. If we use that paper that I find so interesting by Nilsson in Implementation Science in 2015, bringing in system science and decision science, I think we're getting much closer to generalizable theory. I really like that for helping to understand causes. And I also really like the idea that we're able to, tailor and match to setting while still being able to provide some sort of prospective guidance to clinics before they go about the difficult work of reallocating staff and policies and pursuing difficult organizational fixes. You can kind of see why simulation is valued by surgeons, and we're probably all glad when we get in a plane that our pilot is hopefully not flying their first flight and have had some simulation learning. I think simulations are really well adapted to the implementation problems that we have because it allows people to do their learning in a safe environment where no patients are harmed, and to overcome what's so challenging about learning under dynamic complexity in the real world, because a simulation allows you to deal with multiple causes and change your assumptions and see what that adds up to. So I think I'm kind of more at, those are the main spaces that I think about this contributing to in the field of implementation science is helping us show up to our stakeholders and help them come up with a better plan that is likely to work in their context, and not stay at the kind of, it depends. We know it depends, but we're actually trying to take some of the key dynamics that we think we know it depends on, use their local data, and kind of come up with a more optimized solution than anyone would have time to do without these sort of resources.
Sure. No, thanks to both of you. We're starting to get a few questions in, so I'll start sprinkling them in. But wanted to ask one additional one before we get to those, and that's, I think we have a lot of people, and I know from my experience with colleagues at the NIH, when we've been trying to entice more investigators into considering system science approaches to thinking about implementation science, and as I think you referenced before, the PARs have, at least for the last few iterations, the program announcements, have explicitly called out system science approaches as one thing encouraged for the investigators to submit their applications thinking about. And so I was just wondering if each of you might be able to help the group think about what you see as particular barriers to investigators who are interested but not quite sure how to incorporate system science methods in their implementation science work, and maybe how you would suggest some of those barriers being overcome. Maybe Stephanie, do you want to start with some comments on that, and then Lindsay?
Yeah, sure. So I think this is a critical issue for all of us as we're trying to marry these two fields together. Is thinking about, what are the roadblocks? And there are quite a few. So I'll think about a couple, and I know Lindsay will have great input as well. I think it's really hard to gain entree into these fields for investigators who aren't familiar with the jargon and the culture of each of them. A lot of the folks who are making significant contributions to both implementation science and system science methods are outstanding academics, and we have a long history of their publications and their scholarly activity to point towards. But I think sometimes as academics, we can be very exclusive about who's a member of the club. And, you know, I think that that has a lot of unintended consequences. For one thing, it's sort of an artificial academic silo that we've put ourselves into with our training and sort of how we go about becoming experts, you know, whether it's a PhD program or an MD program or whatever else. The whole point is for you to have this very narrow understanding, and you're the expert on this one very narrow thing. But science is evolving to be much broader and much more dynamic than that. So we have to be willing to talk across disciplines, to break down those barriers, and just be more inclusive about the science that we're producing. So I'd say that's one thing. Another thing is that this work, certainly on the system science side, is incredibly time intensive. Whether you're developing a process map from qualitative interview data within a healthcare system, which we've done in our work looking at how patients navigate the financial aspects of their cancer care, or whether you're building a complex simulation model, these things take a lot of time. They take a lot of resources to develop. It's not an 11th hour kind of process. You know, we have to first work with stakeholders to figure out, you know, what the right tool is, and then figure out what the right data are to populate that tool and make that tool function. And they're all tailored. I mean, you know, Lindsay just noted this, that every single one of the system science tools that we're using in practice, every single one of them is very specific to the context that we're working in. And in addition, they're changing over time. So there's this dynamic complexity that is part of our healthcare systems and part of the larger biology of health. It's hard to replicate that in any sort of system science process, and to even attempt to replicate it requires a ton of data, a lot of assumptions, and certainly having experts who live and breathe that context at the table, not just a bunch of academics. The last thing I'll say is I think one barrier that people struggle with is that this work is rife with uncertainty. And so you really have to be comfortable and willing to embrace uncertainty in both implementation and system science. And for me, I think one of my philosophies of doing system science work is that that's the whole point, right? Like our goal is not to get to a single optimized answer, although we frequently use optimization as a technique. Our goal is to try to understand a range of possible outcomes that can result from intervention or from implementation of a particular policy. And it's that uncertainty, it's the richness in the variation that we're able to generate that tells us something about how the system works. Of course, stakeholders sometimes want a point estimate, right? They want what's the base case finding. And we frequently give them that, but I always provide the caveat that, you know, no one can expect that it's going to go exactly as anticipated. And for that reason, here's a whole host of sensitivity analyses to try to provide a little bit more context and a little bit more parameterization around what we might expect to observe in the real world.
Cool. Lindsay, any additional thoughts about the sort of barriers and how we might overcome it to get more folks involved in this?
Yeah, I think Stephanie's great points about inclusion. For everybody, I think this is one of those times where team science is obviously, you know, has to be the way. There's like just no way that we would be able to have all the expertise necessary without a bunch of multidisciplinary folks brought together. I think implementation scientists are ready for that and get that basically to the, you know, right, it's baked in or dyed in the wool, I guess you could say, just to keep lots of metaphors in play. I think that for me, you know, as we grew, we got even more expertise in specific areas, like how to make things scale and how to do iterative design to make our tools really accessible to stakeholders. But the multilingual need to find out how to describe system science to implementation scientists and so forth and find those intersections is something that definitely requires a team. And I think most of us just need to continue to flex until we find the right complement to address our own implementation problem and the needs of our stakeholders. A possible solution that we've been exploring in our team as well is not just team science, but the principles of open science. So now we've got implementation science, system science, team science, open science. Forgive me, but just to define that in terms of a collaborative, free and open, transparent, and reproducible science, we've put all of our models and all of our code on GitHub, so anybody can download them. And you can actually just go to mtl.how, as in modeling to learn.how, mtl.how, in any browser window, and you can download all of our models and all of our session guides and code and everything. And that is something that the system dynamicists have been doing from the very beginning, is trying to make the causes that people are exploring when they're modeling transparent or more white box rather than black box, opaque type of modeling. So one draw to system dynamics for me, for our problem, was not just that it seemed to match the level of decisions and delay problems that we were facing in VA, but also that the tools were meant to sort of start with a blank sheet of paper and help people slowly build their understanding of what influences what, first qualitatively, and then start to validate and check those assumptions quantitatively. And there's open source software that you can download to run the models and check out those things and see it in a picture. Those types of things, I think, ultimately someone on the call may not find that system dynamics is the right modeling approach for their implementation problem, but the fact that those things are out there might help them think about, okay, what makes modeling accessible? Would this work for our community or our implementation stakeholders? And there are some really nice exemplars for ways to make it accessible. And so that part of the tradition might be a good point of entry for folks who are trying to get over the barriers to getting going. And the last thing I would add that I think Stephanie alluded to is just, it does take time to learn all this stuff. And that's, not something that I'm saying really loosely. But I think for me, I always am acutely aware that if I'm meeting with 5 providers, then that's 5 patients not getting seen. So I'm really trying to think about what can we do that just really maximizes the value for the providers and the patients of focusing on implementation issues. And I think that there really are some efficiency gains in developing these skills and competencies across a team, if not as an individual, in terms of how much more quickly you get feedback about your ideas than in the real world. It's really hard to convince staff that the thing that you implemented in March is what's explaining your data 6 months later. But in a simulation, you can really start to design some really nice, tightly controlled experiments to try to upgrade your mental models and those decisions you're making. And some of those efficiency gains are really worth a lot for our providers and our patients. So I think that the fact that implementation takes time is going to be also really familiar for any implementation practice person out there on the call. And so the question just becomes, what kinds of capacities for your stakeholders would you like everybody to have at the end of your efforts? And does modeling add value beyond whatever else you might do at that time? And for us, we thought, yes, it does add value beyond, for example, facilitating things without a model to guide and update our thinking.
Great, thanks for that. And wanted to just start weaving in some of the good questions that we have so far. This one is a bit more of a comment, but I'm going to try and find a more specific question within it. And I think it speaks to this idea that these approaches can benefit greatly from input across a range of different stakeholders. And so the specific comment was saying that people who may not have doctoral level research training may not feel immediately able to participate in this kind of in these kind of system science projects. But I wonder if each of you might give examples about how you've been able to draw upon the expertise of folks who may not consider themselves sort of doctoral level researchers and how they've contributed to building out these different models. Stephanie, do you or Lindsay want to start with that?
Sure. I'd be happy to jump in from our perspective using one of our projects as an example. So I mentioned this complex colorectal cancer model that we've built over time. And one of the things that we've been able to do with this model, and we have a couple of different states that we've simulated, we have taken some of the underlying data about cancer mortality, cancer incidence, as well as cancer screening rates in a particular state, and very specifically looked at geospatially explicit estimates of each of those things down to the county level in our model. And we've been able to go to stakeholders, a variety of stakeholders at the state level to include, our state's Medicaid office, as well as the coordinated care organization arm of our state's Medicaid office and other DHHS representatives, and show them kind of, here's the level of variation that we're observing in terms of cancer incidence, mortality, and we use claims data that is married with BRFSS data on self-reported screening rates to get an idea of what the real screening rate is, county level screening rate. We've been able to take that to decision makers at the state level, but also to folks in health departments who are working with populations that are underscreened and that are low income, and show them these data and say, this is a place, this is an area geographically and demographically where we have work to do. We need to be thinking about implementation of evidence-based interventions in some of these specific areas, maybe not Chapel Hill or maybe not, affluent white communities, but rather the places that are in need and that have the strongest need. And then we can overlay those simulations with some of the evidence from, published trials or other studies in terms of what we expect the gain or the increase in screening rates to be, and project, as Lindsay was saying, on a population level, what do we expect to see in terms of not just screening rates, but if we track that through all the way to cancer detection as well as cancer-specific mortality, what kind of life years gained might we expect to see over a longer time period, and how much cost may we avert by detecting cancer earlier? Now, the interventions that we might implement now have a cost associated with them, yes, and maybe that's a cost to Medicaid, maybe that's a cost to the CDC, maybe it's a cost to a specific clinic, but there are returns on that investment that come later, sometimes as short as a year later, 5 years later, but really thinking about that horizon with the people who are at the clinic, the people who aren't academics, aren't MDs or PhDs, but rather are working with the local populations. In some cases, these are clinic staff, nursing staff. In other cases, it's people who are in a clinical coordinator role or community health workers, and motivating them to say, how can we improve? How can we reduce disparities by being very thoughtful about targeting our interventions? I would say the most impactful information that we've gotten in our modeling process has not been from PhDs and MDs. It's been from people in the community who can help us refine our estimates and the way we're thinking, and really help us figure out where it's going to be most important to go in and do work.
Great, thanks. Lindsay, anything to add?
Yeah, I think there's almost a paradox for me here about the question, which I certainly understand where it comes from. In our work, though, it's been interesting to me that the frontline staff and our Veteran Advisory Partnership were maybe the first to get why this was so valuable, because they know how complex the day-to-day care in the clinic is that they're facing, and they know what decisions they'd really like to inform at the front line. And if I go back to this idea of a participatory research type of epistemology, meaning asking ourselves, well, where does knowledge about implementation come from, and whose knowledge is missing or whose knowledge is privileged? When we started with a blank sheet of paper and asked veterans and frontline addiction mental health staff and addiction and mental health staff, well, how does a patient's need get met around here? What happens before that and after that? And slowly built out our models. It was really a very transparent process in a way that a lot of modeling is not, which is why I'm calling it a paradox. A lot more transparent than maybe regression models. In fact, our statistically inclined colleagues in the center were constantly struggling to understand the shifts in what the model was about in a way that, starting with a picture and drawing it out and try to represent the problem in the picture and benefiting from maybe 40 years of guides on how to facilitate groups in model development and validation really helps a lot. We didn't have to, try this stuff out for the first time. We had a lot of scholarship that helped us understand how to engage folks in the development of a model. And so for us, I alluded to my scientific values that brought me into this work at the top of the conversation. And we increasingly wanted to figure out, well, how could we build these resources in a way that maintained participatory principles, maybe even at the scale of the largest addiction and mental health provider in the country, the VA. And what these tools actually enable is our ability to, yes, offer resources, but make them more equitable, have better access for everybody, bringing them even to the front line where care decisions are being made. And to read in local data and identify solutions that work locally enable us to stay at the level of mutual learning and not come in with a solution from Houston and just try to make sure that, force it into Cleveland, even if it's not a good fit. In other words, they really do allow us to learn with stakeholders in real time to do modeling in this way. So for us, I think that I find it much easier to take a picture of a problem and sort of present it as a straw man and say, what's wrong with this, and iterate with people over time until we get a model that everybody thinks is useful. It really is a great way to go. All of a sudden, the problem is in this thing, and you see people who formerly could never see eye to eye sitting shoulder to shoulder looking at the model of the problem together, and they're working on it together rather than the problem being, say, between two providers and how they see it, and they're on opposite sides of the table, debating it. And you as an implementation facilitator may not know how to help them resolve it. The model can really help with those things. So I don't know if in relaying some of that, I would agree with Stephanie completely that I actually think that these approaches can make the problems much more tractable for people who, maybe are the least quantitatively sophisticated, you might argue, of all of our research and science-based. That's at least been my experience, is that it really does make it more transparent and accessible for those folks.
Great, thanks. So picking up a couple of other questions now, which will, I think, as you'll see, will be somewhat related. But the first one is whether you're able to use theory or models to determine which factors you're going to include in your models. That there's been some experience where if it seems like you're trying to model everything, anything and everything, that you can have a hopelessly complex and not necessarily a well-articulated model. So can either of you talk a little bit about how you use theories or models in the construction of the specific models and what factors are in or out?
Sure, I can start and say that I think it's essential to have some kind of underlying theory that's governing how you're putting together your mental map and your mathematical model. Most of the work that we do is really kind of in the behavioral theory space right now. So I rely a lot on my behavioral science colleagues to fill in the gaps that my own training didn't provide around, how these theories operate. And actually, increasingly, my work is moving more into organizational theory and trying to understand that and bring that into our models as well, because so much of the dynamics we're talking about are multi-leveled. And so thinking about how individuals behave is not sufficient when individuals live within households, within, larger healthcare systems, within larger communities. So I think it is really important to have that connection to theory, absolutely. I wouldn't sort of point to a particular set of theories or frameworks in particular, because I think it totally has to be driven by the underlying question and the underlying context that's being modeled.
Mm-hmm. Great. Lindsay, any quick things to add?
Yeah, I think that one radical thing I learned about system dynamics is the idea that you could incorporate really basic science theory, like the physics of your problem might mean that you have to conserve all your EVP implementers' time in your model, and make sure that there's no way that your model is proposing some sort of local implementation plan or quality improvement plan that inadvertently assumes staff have 150% or 200% of the time that they have. In our healthcare system, from our leadership in DC all the way down to the front line, all clinics were equally interested in knowing, when a team was doing the best they can with their resources. So rather than this being a construct or a barrier from one of our frameworks, time became something that we were explicitly modeling and conserving, making sure that we were not inadvertently growing the total pie of hours, but always coming up with solutions that were working with the available time that staff had. So that was something that really is really a value add, and is maybe even a different thinking about theory than maybe the question or comment came from. But some of our upcoming trials, either underway or that we hope will be funded, will specifically look at this theory that people need better systems thinking skills to make decisions under complexity. So we will test that mechanism in our R01 to see whether indeed, use of simulation modeling improves systems thinking, and whether that explains the improvement in our key implementation outcome of evidence-based practice reach. And we hope to also test another major mechanism, which includes a lot of validated measures from the community-based participatory research tradition, and test that theory model about whether, this approach to mutual learning, equitable access to resources, and shared decision-making, whether that is explaining the improvements, the ability that we don't come in with these predetermined solutions, but build them sort of from scratch with folks.
Great. Thanks to both of you for that. We only have about 5 minutes left, so I'm actually going to take the next two questions and try and mash them together in a way that I hope doesn't annoy either of the questioners. The two questions basically pull in if each of you might briefly comment on how best to overcome gaps in data when building a model and defining the different parameters, and then how you move on and anything you want to say about the process for trying to validate the models once created. Either of you want to shed light on that?
I can try, Stephanie. Should I, or you go ahead?
No, you go first, and then I'll weigh in.
Okay, so two things. One, the first one is to know, at least in our modeling, that we're always starting with, hey, what's the most robust and best data that we have, and iteratively developing models with that in mind. And unlike a regression model, for example, where any misspecified parameter could just wildly make any inferences you might want to draw invalid, in our case, we essentially are building models based on the most rigorous EHR data we have, and data for which we basically have complete data for our population from the EHR. And so we've sort of come up with a unique approach to addressing potential for gaps in data. And since that may or may not be available for everyone who's not working in a healthcare system, I'll leave that one be for a second and just add one last comment before handing to Stephanie, which is that the validation of a modeling project is an iterative, it's a project that goes on over time, at least usually. And so validating your model and its assumptions and calibrating it is something that, yes, there's many known tests to use, which we use, and you're doing that with your stakeholders as you go, so that you're making sure that you have a valid model to inform your decisions. And so that's sort of an ongoing iterative piece that again, there's models for how to do that with your stakeholders as you go.
Cool. Stephanie?
And I would just add to that, so those are great responses from Lindsay. This is the hardest part about modeling, is finding the right data, finding the most timely data, the most complete data, most appropriate data for the question that's being answered, and then continually checking it, troubleshooting it, and doing calibration really when it's possible, either reserving a set for validation or having a sort of new validation set that can be projected. But at the end of the day, we probably spend 95% of our time trying to identify, accumulate, and make sense of data that we have, and then troubleshooting our models when the data don't pan out to project the kinds of things that we expect. So this is, the person asking the question has really hit on, I think, the most important part of model building, and it's not. It's certainly not easy, but it's something that we all think about.
It's also, if I could add one last comment, that what's so cool about it is the opportunity to learn from that as you go, and not just have that be a problem that stymies us, but be something that helps us, as you were just saying, Stephanie, improve our understanding of the phenomenon in the process of identifying, accumulating, and evaluating the data and making use of it.
And to do a ton of sensitivity analyses to think about the uncertainty and the source of the uncertainty in the data.
Exactly.
Wonderful. There is actually, if I can ask somebody to throw in, if we can, just because another question popped up, for one of you to take on. So there was a question about whether modeling is always done at the local level, and alternatively, how modeling might be different if you're thinking more in terms of, modeling the impact of national or international guidelines or different clinical decision support tools. So would one of you just want to say the degree to which some of your work has extended, not just focusing on within local communities, but modeling at a higher level of the population?
Stephanie, why don't you take it? I think local is actually the least common way to do it.
Yeah, sure. I mean, a lot of the models that we build are larger models that address, for example, cost effectiveness of a particular treatment or intervention or program, and then those can be much more globally applicable. When we get into, my experiences, then we get into really complex dynamics and needing to understand complex multi-level influences, that frequently ends up taking on the flavor of a locally specific model. Whereas when we're just doing, cost effectiveness more generally, that can be much broader in its application. But the more you really need to understand the context, which I think is always important for implementation science, in my experience, the smaller the focus of the model has to be to get it right.
Perfect. So thanks to our wonderful experts. Thanks to all those who are tuning in. I'm going to just turn it over to Sarah to close us out.
So I'm going to echo my thanks to Stephanie, Lindsay, and David for their time and all of your attention and great questions today. As a quick note, your feedback is important to us, and we encourage you to complete our online evaluation, a link to which will open in a new window once this session is concluded. An archive of today's session will be made available shortly on our website. Thank you again for joining us, and we hope you'll join us next week for our second fireside chat for the month. We will be looking at qualitative methods in implementation science. Thanks so much. You can disconnect at this time.
Thanks, everybody.